in figure, x, y and x dash, y dash are two parallel tangents. So this is parallel to this, to a circle with center O, and another tangent AB with point of contact at C intersect xy and x dash, y dash at A and B. Prove that angle AOB, this particular angle, is 90 degree. So how do you go about doing it? So I'll give you a clue. One of the things that we have to do is we need to join OC. Okay. Now let's begin our proof. To prove angle AOB is equal to 90 degree. How will we go about doing it? First, we did a construction, right? We join OC. Then we have the proof. See here, PCQ are point of contact, is it not? As P, C, Q are point of contact of tangents xy, x dash, y dash, and AC, AB. This implies, so what can we tell with this? We can tell that angle OPA is equal to this angle OCA, which is equal to, that is this angle OCB, which is equal to angle OQB, and this angle. All these angles are equal to 90 degree. Reason, as radius and tangent are perpendicular. Next, see the funda here is we need to prove this triangle is congruent to this triangle. And similarly, we need to prove that this triangle, okay, is congruent to this triangle. That's the funda. So how will we go about doing it? We'll tell that AP is equal to AC. Then we can also tell that CB is equal to BQ. Why? The length of tangents drawn from an external point to a circle are equal. Okay, so these are the initial things that we can write without second thought. It's quite simple, it's obvious. So once we have this fact, the next is making use of this and proving what we want. So I'll consider PAPO. So consider triangle APO and triangle ACO. So what can you tell about this two? So we already know few things, that is angle OPA is equal to angle OCA, which is equal to 90 degree. OA is common, and we have OP is equal to OC, which is the radius, right? So since we have this, therefore by RHS congruency, triangle OPA is congruent to triangle OCA. So how will this help? See, the point is we can tell that angle A is equal to this angle is equal to this angle. Similarly, if we prove that this angle is equal to this angle, okay, This is a straight line and we can prove something. So that's the whole idea. So basically, I have to prove that this particular angle is equal to this particular angle. And so, you know, a plus b plus b is equal to 180, and we can prove a plus b is equal to 90. That's the whole agenda. Anyways, I'll show it to you. If you're not understanding, you will understand in a second. So by CPST, we have CPCT, corresponding part of congruent part of corresponding part of congruent triangle. Angle POA is equal to angle AOC, which we'll call it as A. We'll call this as equation 1. Next is, similarly, by considering triangle OCB and triangle OBQ, right? We have OCB is equal to OQB, which is equal to 90. Then OB is common, and we have a radius that is, if I'm right, I think it's OQ and OC is radius. I hope I'm right. OQ and OC, yes, I'm right. So by what congruency? By RHS congruency triangle, OCB is congruent to triangle OQB. Now, by CPCT, angle QOP is equal to angle, what is it? COB. We'll call this as B. Right? So with all of this information, what can we do? There's one more thing that we need to talk about. We need to talk about the line that PQ is the diameter, and thus this is a straight line, and so this will add up to 180 degree. Without that, the answer is incomplete, as x, y, and x dash, y dash are parallel tangents, right? This implies POQ has to be the diameter, right? PQ has to be the diameter, right? And we can tell by angle some property of a straight line. We have the 4 angles, A plus B plus B should be equal to 180, right? Okay, so 2A plus 2B is equal to 180 divided by 2, divided by 2, divided by 2, and we have A plus B is equal to 90 degree. This implies angle AOB is equal to 90 degree. That's what we had to prove. Is it not? Hence proved. Okay. Right. So this part you can understand better with the diagram. I had a diagram on the site, so I was able to do it. So you guys can draw the diagram and understand that part of the answer again. Well, this is the entire answer. You can pause and have a look.